All right, hi guys. Today we're going to be reviewing atoms in the periodic table for your formative today. Special hi to Miss Sexton students because I'm making the video today, but Miss Sexton will be making videos for my class soon. So let's go ahead and get started. Before we get started, actually there is a little periodic table atoms joke right here. It says, don't trust atoms, they make up everything. They really do. That's the definition of an atom. And they are the building blocks of matter, meaning every single thing in the world is made up of atoms with as long as it's matter. So energy isn't made of atoms, but everything else is. Atoms are made up of three subatomic particles. The three particles are written right here and shown in this picture. The first particle is an electron. Those are negatively charged. And those negatively charged electrons go outside of the nucleus of the atom, which is the center. They go around in this place called the electron cloud, and more specifically, they go in their own electron shells. The second subatomic particle are these orange dots right here. These are neutrons, and they are neutrally charged, which means they don't have a charge at all. The second subatomic particle are the protons. Those are positively charged, and both the protons and the neutrons can be found in the nucleus. So protons and neutrons found in the nucleus. When I compare the masses of them, electrons are super, super small. It takes over 1,800 electrons to make the mass of one proton. So electrons, even though they're included in atoms, they don't really affect the mass. Neutrons and protons, however, are about the same size and about one atomic mass unit. So if I look here, there are four atomic mass units because I have two neutrons and two protons. That corresponds to the atomic mass, which is on the periodic table. That's right here. So I pulled this one off, helium, right here. And the atomic mass is 4.003. The 0.003 could be due to two different things. The first, and that electrons are super small, so they don't account for a whole number. Or the second thing would be that there are varying variations of this atom, meaning there could be a helium atom with only one neutron. If you remember, we learned about those. Those are called isotopes. Or there might be a helium atom with three neutrons, and that would mean its atomic mass would be around 5. This number right here is an average of all of the masses of the different isotopes. So down here, we have atomic mass, and that is equal to the protons plus the neutrons. So protons plus neutrons make up the atomic mass. And then up here, this is called the atomic number, and the atomic number tells me the number of protons. It also will tell me the number of electrons if the atom is a neutral atom, which means that the electrons are not interested in combining and forming anything else, any other compounds with another atom. This right here, this He, is what we call the element symbol. Okay, so now the specific location of an element really tells you a lot about that atom. So let's look at the next slide. Right here, we have chlorine. So chlorine is right here on the periodic table, and then I made a bigger one down here for you. And then here's a drawing of chlorine. So chlorine, if I look at the periodic table, is in columns are up and down, column 17, column or group 17, and it's also in row or period. Let's follow chlorine over, period 3. So row, period 3. Now, on the periodic table, it will tell you a lot about what that means for the atom. For example, so group 17 tells me the number of valence electrons. So this means valence E minus because electrons are negative. So if I look at the groups, I can see that in column or group 1, all of these elements will have 1 valence electron. In group 2, all of these elements will have 2 valence electrons. If I look at the center right here, These do not follow the valence electron rules. You'll learn about that when you're in chemistry later on, but just trust that groups 3 through 12 don't follow the rules. Groups 13, 14, 15, 16, 17, 18 do follow the rules, but you have to look at the second digit. So all the elements in group 13 have 3 valence electrons. All the elements in group 14 have 4. All of the elements in group 15 have 5. All of the elements in group 16 have 6. All of the elements in group 17 have 7. And all of the elements in group 18 have 8. So chlorine is in group 17, which means it should have 7 valence electrons. So 7 valence electrons. Put that on the next line, okay? And we can check that actually. If we look at this picture right here, we can look at the outermost electrons. Those are what valence electrons are. The valence electrons are the ones that they can meet up with other electrons from other atoms of different elements, or maybe even their same element, and they can form compounds. So we have 1, 2, 3, 4, 5, 6, 7. So that makes sense. Group 17 should have 7 valence electrons. The row, however, said row 3, tells us the number of electron shells. So if I look at my picture, that should make sense because I have 1, 2, 3 electron shells. We'll do another example now. Let's look at xenon. Xenon, we'll find it on the periodic table, is right here. So it is in group 18, and it is in row, let's follow it over, row 5. So row 5. So based off of what we just learned, we said that if it's in group 13 through 18, it will take its second digit as its valence electron. So 18 would mean 8 valence electrons. And row 5 would mean 5 electron shells. So let's look to see if that makes sense. So we'll count 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, and then 5 electron shells. Let's check. 1, 2, 3, 4, 5. So what elements want to do is they constantly want to have 8 valence electrons. All of these elements in this column are noble gases. Our noble gases are stable, which means they don't react with other elements. So anything that has 8 valence electrons is happy and it's stable. Our previous example, let's go back there to chlorine. Chlorine had 7 valence electrons, which means it only needs 1 more to become a stable element. So 7 would probably combine with these guys over here in group 1, any element, to make it stable. So chlorine might combine with Na to form NaCl, which is table salt, which is why it's such a stable compound. So anything can combine as long as in their last shell they have 8 valence electrons. That's what makes them happy. Let's move on to the next example, and we'll look at phosphorus. Phosphorus is right here. It is in group 15, and it's also in row 3. So group 15, row 3. Group 15 means second digit. Group number means number of valence electrons, so 5 valence electrons, and row 3 means 3 electron shells. Let's check with our picture. So 5 valence electrons, 1, 2, 3, 4, 5, that checks out. And then 3 shells, 1, 2, 3, that checks out too. The other thing that I could calculate with this would be the number of protons and neutrons and electrons. So like we said that the atomic number, which is right here, would be the number of protons. This would be 15 protons. And then the atomic mass also tells me the number of protons and neutrons. So I'd have to do 31 minus 15 to get the neutrons, because this is protons plus neutrons minus protons will just give me neutrons, so 16 neutrons. And then we also said that the number of protons is equal to the number of neutrons. This would be the number of electrons is equal to the number of protons. So this would be 15 electrons. I'm going to go back and check those other ones too. So xenon would have 54 protons. It's also going to have 54 electrons. and 131 minus 54 is 77 neutrons. We'll go back to chlorine. 17 protons, 17 electrons, and then this would have 18. 35 minus 17 is 18 neutrons. And if you could open your INBs up to your WWK pages, that would be amazing. Our first WWK is an atom. It's the smallest building block of matter. Please write that in your INB. You can pause the video while you write that. The second WWK is group/column. That means they're the vertical or the up and down columns on the periodic table. You can pause this video while you write that one. And then the third one are the period/rows. Those are the horizontal or the left/right or the rows on the periodic table. You can pause the video while you write that down. Next, we're going to go to our our key concepts. So turn to your key concept pages, please. The first key concept is that atoms are made of protons, which are positive. That's what it says, parentheses and then the plus sign. Neutrons, which are neutral. They have no charge. And electrons, which are negative. You can pause the video and write that key concept down. The second key concept is the atomic number indicates the number of protons or electrons in a neutral atom. You can pause the video and write that one down. And then the third one is the group number tells you the number of valence electrons. Those are the bonding electrons for groups 1 through 2 and 13 through 18. So for groups 13 through 18, use the last digit to determine the number. You can pause the video and write that one down. And then the fourth one says the row number tells you the number of electron shells. You can pause the video and write that one down. And then the fifth one is the number of protons is found by subtracting the atomic number from the atomic mass. You can pause the video and write that one down. To wrap up today, first thing, we want you to reach out if you have any questions before. And then second, we want you to complete your formative on your own without your notes. The quiz is linked on today's 4-13 Canvas page. And then a couple reminders, we're gonna have our first summative on Monday, 4:20. So make sure you're going in office hours and you're reaching out if you need any help. And then the second thing is that we are gonna have a whole 7th grade science class Kahoot this Friday. So Kahoot Live on the 17th at 1:30. So if you need to arrange to get a device from your sibling or something, everyone can join and then we'll run a Kahoot that way. Alternatively, if you can't join the Kahoot, there'll still be a review for you to complete for your summative on Monday. And that's everything. Let us know if you have any questions. Thanks.